I'm Harold Ogden, and I'm here this morning with Carrie Roberts and Kirk Sayre. We're going to present on VBA Stomping, Advanced Malware Document Techniques. I'm a systems engineer turned blue team a couple of years ago. I work at Walmart doing security operations and continuous monitoring. And I'm on the Dynamic Defense Engineering team, blue team at Walmart. Carrie Roberts is a developer turned red team. And she's a senior red team engineer at Walmart. She's got her master's in information security from SANS Technology Institute. And then Kirk Sayre is academic turned, or security tool researcher turned blue team. He's also on the Dynamic Defense Engineering team, the blue team with me here at Walmart. He's got his PhD in computer science at University of Tennessee. And before we jump into the more complicated process of VBA stomping, we're going to start off with just some real VBA crafting fundamentals for crafting malicious documents that you may be using as a part of an engagement, and just to educate maybe if you're on the defense side on some of the things that we're seeing real malicious documents do today that we've seen be very effective. So I know this is something everyone's probably very familiar with at this point, but the old Office 97 format is a proprietary compound OLE file. It's not compressed, but some of the parts of it are. And it's usually, as we'll look at in a minute here, named like .doc or .xls. We've all seen that a million times by now. And then in 2007, the new OpenXML format came out. The whole file is compressed. It's all zipped, and you can unzip it with 7-zip. It's an openish standard. It's really easy to unzip it and look at the individual parts inside of it. So one of the things that we see taken advantage of, and it also will work to your advantage, is that extensions can lie. So just because something's named .xls doesn't mean it's the old 97 format. So that's one of the things that you can take advantage of. So the XLS will open both the XLS and XLSM format. So you can have an XLS file that'll run macros on the new OpenOffice format. But if you have an XLS file, this is a really important point, you cannot have a macro-enabled document that's XLS extension. Excel and then Word for DocX, they just refuse to run macros out of those extensions. So you don't ever want to name your files that way. So if you're going to have to pick a extension, XLS is a great extension to pick, and you can rename your XLSM file after you've done whatever you want to the document, and it will run. That can confuse defenders and confuse signatures, because if they are looking at an XLS, they expect it not to be compressed, and they may be running signatures against the file in its raw form, when really they need to be decompressing it first, unzipping it, and looking at the subparts of the file. The XLSM format, while it can contain macros, I would avoid, because no one ever names a file that unless it's going to contain macros. So it's like a huge red flag immediately for defenders and for signatures. So object linking and embedding, if you're not familiar with it, it's a proprietary format Microsoft developed. Like I said earlier, 97 format. The whole thing is in one big OLE file, but in the Office 97, in Office 2007 and Plus in the OpenOffice format, VBA that you write is going to be stored in a OLE compound file that's clearly separate from the other parts of the document, and it's going to be saved as VBA project.bin inside that zip file. Okay, so one of the first things you can do to make sure that you're not getting caught by detective mechanisms is just spend a little bit of time building your own VBA payload. And if you go use any of the off-the-shelf frameworks, it's going to be kind of a hit or miss for you, usually about 15, 20 plus detections across the 60 antivirus that are in VirusTool today. And so one of the things that you can do is just start building these yourselves. And one of the things you're going to want to do, you can do other things here. This is not a comprehensive list of things you can do in a malicious document, but you're going to want to create a process, whether it's create a MSHTA to go download your payload. If you want to run PowerShell, you want to run some sort of an additional process out of your document. You can do that with shell. You can create a wscript.shell object and run it. You can use WMI to do a process create. So to start with, here's about the simplest payload that you can put into a malicious document. This will go get PowerShell from that remote location, and then it'll eval it, it'll run it, and so you can stage your payload somewhere else. But the problem with this is that you're signature fodder, right? You have things in here that are really easy to signature on, and a lot of antivirus companies have done this because this is commonly used by malware today. I took this payload from a malicious document that was being used to deliver legitimate malware. So it's being looked for. So we're going to go through a couple of steps here to make this get targeted a little bit less and be more evasive. So we're going to obfuscate first. Then we're going to do some generalization of like variable names and make sure that those things aren't being looked at as carefully. Then we'll do some anti-analysis at the end to make sure that like things like sandboxes are a little bit less effective against us. So the first thing we can do is ditch shell. And one of the things you go straight to is WMI. WMI, when you see it just in the clear, is a great indication of a malicious document. So you go from shell, which is ambiguous, it could be a business process, to WMI, which is probably like Empire, because Empire uses that by default. So at first, it seems like going to switching to WMI could be a bad idea because our initial payload is being hit by 21 antivirus vendors. We switch to WMI using the default Empire WMI process create, and we go up to 27 detections. So we took a step back. Right now, almost half of the antivirus vendors are going to catch us. But then, if we take the Empire payload and we minimize it, we get rid of some of the optional things there, like that set the window, the show window to 0, which makes the PowerShell won't blip at the bottom of the taskbar for like a half a second. We lose a little bit there, but now we're back down to down to 23 detections, which is still, again, a step back from where we were. However, these are the things that are being targeted by signatures that are out there today. Like the antivirus companies are looking for these to say these are bad documents. This is bad VBA. These are things that we want to block coming into an environment. So WMI is bad, but the get object we're using to create that WMI is ambiguous. It's not necessarily bad by itself. It's just those like win, MGMTS, and other common strings. So if all we do is reverse those strings, we don't spend a whole lot of time here, and we are now down to 7 detections. So that's like the most simple of obfuscation. We see malicious documents and malicious VBA do this, but people have written signatures for reverse strings. People look for backwards HTTP and the slashes and things like that because they know reversing these things happens. So it's not going to be a very future-proofed obfuscation method for you. But that's all it took to go down to 7, was we just flipped everything backwards. So now you can't see those in their plain form. If you're going to build a larger payload, you don't want to keep calling string reverse over and over. So we will often stub that out to a function, and then you'll just call whatever function you move that to over and over so that string reverse won't show up like 50 times in your document. So you can't always avoid using a method, but if you have to use a method, only use it once, stub it out like we looked at before. Obfuscate all the strings in the data that you can so that it'll make your payload hard to signature, and use variable and function names that are hard to signature as well. So we've been talking about using Excel in this so far, and there's things that are really common in Excel, and that's numbers and like calendar apps people have written in Excel macros. So the first thing we're going to do is take our payload and we're going to like in this case, rot 19 all of it, and just store it as one big array of numbers. We're not going to store it in like an array with any kind of delimiter because those get looked for. Those are really suspicious in macros, so it's going to be one big block of numbers, and now our payload looks like this. So then we're going to name all of our functions that we use to decode this after months of the year and days of the week. And if you try to write a signature looking for days of the week and months of the year in Excel, then you're going to get a lot of false positives. So this is something that we can do to hopefully not get detected. And then our main function there goes and does to do all the decoding. So we'll call June anytime we want to decode a string. And that's our main function there. And now you'll notice that when you do a WMI process create, normally the arguments are going to be like 0, 0, null. But VBA is really nice, and they will take uninitialized variables and return them as nulls or zeros for you. So you don't have to leave that pattern intact for signatures. So you can just say, I've never used these variables, I'm going to put in these random words here, and these are going to return nulls and zeros for me. And these here are our win-MGMTS and our win32 process. So these are no longer plain strings that signatures can key off of. So now we're back down to 7, where we were with the string reverse. However, now we have the support for an arbitrarily large payload. We can bring anything we want with us and make it as large as we want, and it's going to look the same as this because it's all encoded in this big encoded payload. But we can take it a little further by implementing some anti-sandbox techniques. So the first one we're going to use has been documented many times, and we took a lot of inspiration from like PA fish macro, and there's in Ebola, there's been some good talks about keying so far here at Derbycon. And this is really effective against the VMs that are not domain joined, right? So we just see if the computer name is the same as the user domain. And if it is, then just don't run. And we just use an English dictionary to populate the variable name so that it's not ever going to be the same. And then we do an anti-fake net technique, and we saw this used by like the WannaCry malware, where you just go try to access something that doesn't exist. So in this case, location.microsoft.com is a non-existent domain. So if we're inside of a VM and they're fake netting us, it will respond, and we know we're in a VM with fake net, and we don't do anything. Now, the interesting thing here that we didn't initially expect is that our detection rate went down when we implemented these things. So we went down to 6 upon initial implementation. Then, whenever we obfuscated, we went down to 3, which indicates that there's some emulation going on inside these AV engines. So by implementing anti-fake net and anti-virtual machine analysis, the analysis of some of our VBA macros was failing, or it was not detecting it as malicious. So now we're down to 3 detections, where we started at like 21 to 26. And now we're at a pretty good spot where we're evading the majority of antivirus, but we can take it further. And so we're going to look at how they're analyzing these VBA macros. So the security products are looking at the compressed VBA source code to analyze all of these things we've written so far. But what if we didn't need the source? What if we didn't need that information that all of the analysis tools are looking at? So the next thing we're going to do is looking at stomping the VBA, but the macros will still run.
Hello, Carrie Roberts here, and I'm going to talk about VBA stomping. So before we get into VBA stomping, let's talk a little bit about how the macros are stored. And Harold mentioned they're stored in a file called VBA at least by default. That can be changed, but they're stored in, or can be stored in 3 different ways. First is the source code, like what the developer actually types in. So a lot of what you just saw, that it's stored in that format, but it's compressed, so it looks a little bit jumbled, but a compressed source code. Next is as a compiled pseudocode, kind of like assembly language. We call it, it's called Pcode. And that's actually what executes most of the time in a document. And the third is exe codes, but I'm not talking about that here, but Dr. Bonchev has a write-up on it on his GitHub there, if you want to read more about this. So on your left, you see the Visual Basic Editor, which you use to develop your macros from Word. So you see a subroutine there, auto open, with a message box ABC. The way that's stored in the Word document in the VBA project.bin file is shown in blue down there. You see the hex on the left, and on the right you see any readable string. So you see sub, auto open, message box, ABC, and it's a little jumbled because it's actually compressed, and you know, it kind of seems like it's not compressed that well because it's like bigger. But they call that compressed VBA. So on the right is the P code. So up in the black, it looks a little readable there, but that's just as a favor to us. We can kind of see the function definitions. We can see a string of ABC declared and an argument call. But when you look at that actually in the binary file, it looks like that down below, a bunch of hex, which if you look at the readable strings, the only thing you can really decipher easily from that P code is the string ABC. So those are 2 ways it's stored in the VBA project.bin file. I pushed the wrong arrow. Okay, so we're going to play a little bit with the compressed VBA source. So we're going to go into the VBA project.bin file, and we're going to change the string ABC in the compressed source code to XYZ and save it and see what happens. Okay, so here we have our ABC document. It's got that simple message box pop up. And we're going to open this with 7-zip. So we go to 7-zip, open archive. The nice thing about 7-zip is it can open up a zip file and let you look inside and even edit something. And when you exit, it'll zip it all back up for you. So you don't have to like unzip it all and then rezip it all manually. So here we have the .docm file opened, and we see it's just a compilation of a bunch of other files in directories. So we have a doc properties directory, a Word directory. Inside the Word directory, you'll find the VBA project.bin. And that's the thing we want to edit. So we right-click on this, and we're going to say open outside, which means open it with our third-party program for opening bin files. And I have my system set to open a bin file with the HXD hex editor that I have installed. So when I click open outside, it's going to open up right up in the hex editor. And we're going to search for the string ABC, because that's what we want to play with. So we search for that. And the first place we find it, we can recognize the Pcode here. We see the string ABC, but we don't understand much else there. And down below, we see it in the second spot. And we see that that's the compressed VBA source. So we kind of can read sub-auto open message box ABC. So that's where we want to play with. So we're going to change that ABC string to XYZ and see how Word behaves. So we save that. We exit out of here, and again, 7-zip is nice because it says you change this file. Do you want to zip that back up and make it part of the original docm file? And you say okay, and then it just does that for you. You could do this with a regular zip tool, but it's more steps. So that 7-zip's nice in that way. Okay, so now we have the ABC docm file where we've tinkered with the VBA source, but we haven't touched the Pcode. So before we enable content, we're going to go over to the Developer tab and bring up the Visual Basic editor. And so in the Visual Basic editor, it looks like we have a macro that when we enable it, it's going to pop up a message box that says XYZ. And so we're okay with that, so we go ahead and we enable content. But to our surprise, it doesn't say XYZ like it said it was going to say. It says ABC. So clearly, it was the Pcode that got executed there and not the, this thing's talking in the background. Is this muted? It's distracting. I think I got it. I got it muted. I can quietly hear myself talking in the video behind. So now we go back into the VBA editor, and we see that last time we looked, before we enabled macros, it used to say XYZ. When we enable macros, it actually prints out ABC, and then we go back into the Visual Basic editor, and it's been updated, and now it says ABC. So we start to think that we're losing our mind. So what you see isn't necessarily what you get. So we saw that before we enabled the macros, if we went to the Visual Basic editor, what was displayed there was the decompressed source code, that thing that we had tinkered with. But when you enable macros, what actually executed was the Pcode that we hadn't played with. And then when you visit the VBA editor, you no longer see the decompressed source code that was tinkered with. You see the decompiled Pcode. So what actually gets executed, if the Pcode is compatible, it's the Pcode that will run. And so in this example, we had compatible Pcode, so the Pcode ran, not our tinkered VBA source. But if the Pcode's incompatible, Word will take that source code, recompile it, and run that Pcode, and those two things will match. So that brings us to VBA Stomping, which is, instead of just tinkering with the VBA source, let's just completely wipe it out. It's not needed if the Pcode's compatible. So on the left, you see that we're just taking our hex editor, we're highlighting the VBA source, and we're telling it overwrite it with 0. So down at the very bottom, you see what used to be the VBA source is now all zeroed out, and we save that. So if we go open that document up in Word, and we go to the Visual Basic editor, and then we see nothing. So as far as we can tell, there are no macros in this document. So we might feel comfortable to enable them, but as soon as we enable them, we get a message box pop up, and stuff suddenly appears in the Visual Basic editor. So this can be pretty tricky. I know personally when I get a macro-enabled document that for some reason I need to enable the macros, I always switch over and look, does it seem reasonable for me to enable these macros? What kind of bad tricks are my teammates playing on me? And so you switch over there and you're like, oh, it's just going to do this one thing, or there's nothing here, that's odd. And you go ahead and enable macros, and then it can do anything it wants, different from your impression of what it was going to do. And as Harold mentioned, most AV scanners are looking at the compressed VBA source, because, I mean, you can see from that slide that it's much easier to understand the VBA source than the Pcode. So that's the easy way to write signatures. So this can bypass a lot of AV. This idea is not new. Dr. Bonchev gave code and also proof of concepts for the earlier versions of Office for VBA Stomping, although he didn't refer to it as VBA Stomping, so you can review that work there. We mentioned that the Pcode would only run if it's compatible, so the VBA version that the creator uses to create the document needs to match the VBA version of the victim, and that's pretty tightly coupled to the Office version. So if the attacker can determine the Office version of their victim, they can build this payload just to run on their system or that version of Office. So how we can deal with this as an attacker is we can analyze the user agent string that we get. The user agent string is a bit of text that's sent automatically by email clients and web browsers when information is fetched from the web. So if we look up information, if we look up user agent strings, we can determine things like Office version and Windows version, which helps us target that victim specifically with the Pcode. So for example, I can send an email to my victim with a link to an image, and when their email client goes to fetch that image so they can display it to the user, that image is on my server, and when it fetches it, it'll include the user agent. So now, without the victim really doing anything except receiving an email, I have their user agent string, which I can analyze, figure out what VBA or Office version they're using, and then build my payload specifically for that victim. One thing that can be done for anti-analysis is to include an application.quit at the end of the macro. So down here, we see that we have a VBA Stomp document. It looks like there's no macros, but there is in the Pcode. At the end of this macro is a call to application.quit, like shown on the left. So you can imagine the attacker doing something nefarious and then calling application.quit. So that as soon as this runs, we know that the true source is going to pop up in this VBA editor. But if the analyst doesn't have a chance to look at it before the application quits, it's going to be difficult to figure out what this malicious document does. So here we're going to enable content, and then before we can see anything in the VBA editor or analyze it, it's quit. So that's a bummer because we really don't want to look at the Pcode because that's difficult. We know that Word knows how to decompile that Pcode, and we want it to, but as soon as it does, it exits Word and we don't get to see it. So we did come up with a way to deal with this problem so that we could analyze documents, at least for Microsoft Word. And so we've got this same document over here on the right. We found that if you delete the VBA data.xml file, it'll stop any macros from automatically executing. So this is exactly what we want. So we're going to open this document with 7-zip again and go into the Word directory and just delete VBA data.xml. It's not the VBA project.bin file that contains what we've talked about previously, but it's a XML file describing the macros. We're going to delete that and go ahead and save that. Okay, so now we're going to open that document. That's the same document as before, but we've deleted the VBA data.xml file. So we see no macros because it's been VBA stomped. Last time we enabled content, everything went away. We didn't get to see the code. But this time when we enable content, it pops up and we see what would happen, should have happened, could have happened, but didn't. So now, presumably there's a bunch of nefarious code there that we can analyze and and the application doesn't quit. So this is a trick to get Word to decompile that P code for us, let us look at it without executing it and then exiting before we can look at it. And this works to disable all auto execution type routines. So it's typical to use auto open because that's designed to run as soon as a document's open and macros are enabled. But there's other tricky ways to get macros to run, such as when an image loads, run this macro, which an image always loads when you open the document. Or like when a toolbar menu is added to the toolbar. I added a link, a Black Hills post there, how to fish with PowerPoint, because PowerPoint doesn't have any sort of auto-open kind of method. So if you want to fish with PowerPoint, you need another way to get it to auto-execute. So there's a technique there that will do that. This will also disable those type of techniques. So I'll turn the time over to Kirk, and he's going to give us some real-world VBA stomping examples.
All right, so we've been looking a lot at like the general ideas on how this works, what you need to do to confuse AV, confuse analyst, and things like that. And so for those like teaching purposes, we've gone through like some small examples with message boxes and things like that. But now we're going to take a look at how does this work if you use it with like a real world, like legitimate maldoc. So the maldoc that we picked for this example is an Emotet maldoc from the wild, from the actual Emotet campaign. We specifically picked one that is fairly old. So this is something from back in June. And so this is old enough that a lot of kind of like the trailing edge AV companies have put some sort of detection in for it. So for this particular doc, it has a pretty high detection rate. It's up at 39 out of 60 detections. So to test out what sort of effect doing VBA stomping on like something like this that has a very high detection rate is, we wrote a small script that would automatically do the VBA stomping on like any sort of document that we give it. So for our script, it goes and just wipes out the compressed VBA source code with a series of randomly chosen bytes. So we just ran this tool document through our tool, so like a little run a single script. And what happened was we went from 39 out of 60 detections down to 9 out of 59 detections. So this is a document that had a very, very high detection rate. With very little effort on our part, we were able to take that document and drop off 30 of the AV companies from detecting that document. So that indicated to us, since I'm on the blue team, that this is something that we need to take a look at. How do we, like if this starts getting used on campaigns out there, what are we going to do about this? So to show you an example of like what sort of problems this causes for a defender, we went and took our stomped Emotet document and ran it through like a lot of the tools that we use as analysts to try to work with malicious documents. So one of the main tools, big tools that we use when we're analyzing these documents is an open source tool called Ole VBA. This is a tool developed by Philippe Lacage. And basically what it does is it decompresses the VBA source code for you, shows it on the screen to you so you can work with it, and uses some heuristics to tell you if there's like suspicious things that you should look at inside this code. We can see that whenever we run Ole VBA on our stomped Emotet document, first it crashes with a exception, and then just gives us like no useful output at all. Same thing with like a tool called Ole Dump that's written by DDA Stevens. Ole Dump allows you to work with Ole files. It's more for kind of like getting in with a lot more detail on what's going on in the different Ole streams and things like that. So OLE dump doesn't crash, but whenever we dump the compressed, what should be the compressed VBA out of that stream, all we get are a bunch of garbage characters because we just overwrote them with random bytes. There's nothing there that we can work with. And, another tool that we use heavily every single day at Walmart is a tool called ViperMonkey. And ViperMonkey is a VBA macro emulator that actually uses emulation to tell you what a VBA macro would do. So this is, again, a tool that was originally written by Philippe Lecage. Since he wrote the original version, we've kind of taken over the maintenance and extension of that at Walmart. We put this through ViperMonkey, and again, we just see garbage. We're getting no useful information out of this at all. So far, none of the tools that we use for trying to work with malicious documents, none of them are giving us anything useful at all. So, let's see. Where'd that go? Okay, and then final tool that you can use for looking at the OLE looking at the VBA source code is the SIG tool utility that comes with ClamAV. It has an option for dumping out compressed VBA source code, and SIG tool handles this the most gracefully of all the tools, which is there's no compressed VBA source code there that I can work with, so it does nothing at all. So what can we do about this? So all of these tools that I've shown there before are all concentrating and working with the VBA source code inside the document. That's nice to work with because it's readable, it's understandable, it has lots of strings and recognizable functions in it that make it really easy to key off of as a defender. What is not changed whenever you do the VBA stomping is the compiled Pcode that's in the document. So Dr. Bonshev on his GitHub there has a tool called Pcode Dump, which is a Pcode disassembler. And so we're able to take a look at here. This is a snippet of Pcode from the Stomped Emotet doc. And we can see that the Pcode from the original document is on the one side. The Pcode from the Stomp document is on the other side. And they are byte for byte exactly the same. So the stomping does not, by design, does not affect the Pcode at all. So that kind of tells us where we need to go as defenders for how to deal with this if this is used against us offensively. So like Carrie and Harold pointed out, a lot of like the signature-based detections out there are specifically targeting the VBA source code that's in there. If you also include signatures that are based on the Pcode rather than on the VBA source code, you're then going to be able to detect these and not get fooled whether or not there's VBA stomping going on or at all. Then here's like the obvious one for dealing with VBA stomping is if it has not been stomped, the VBA source code in there should match up with the Pcode, and if they don't, that throws up a big red flag. And then finally, the end goal of the attacker is to actually have something happen to accomplish their purposes. So the document is going to need to actually be able to execute and run. So you can just run this in a sandbox and check for the same sort of malicious behavior that you'd be looking for, whether it was stomped or not stomped. Now, one caveat with the sandboxing is that if it was VBA stomped, the document is only going to execute and work in the environment that has the correct VBA version. So if your sandboxing solution does not open these up and sandbox them using multiple Office and Windows versions, there's a potential that you will miss the malicious behavior from a VBA stomp document. So what do these defenses look like if you implement them? So what we have up here is an example of a signature that's written based on the Pcode rather than the VBA source code. So this is a Yarra Signature. There are like a few AV tools out there that allow you to include custom Yarra signatures. And so what we have up here is a signature that is looking for lots and lots of calls to the VBA mid function. So pulling out like a chunk out of a string. So mid is used by a lot of in the wild maldoc campaigns for decoding their payload. Typically, you don't expect to see like 75, 100, 200 calls to mid in like a regular business process document. So seeing lots of calls to mid is kind of like throws up a flag as a defender when you see that in your environment. So if you ever done any work with like developing signatures for like PE executables or like executable files in general, like the sort of thought process that you use for writing those sort of signatures, it's very similar to the thought process you use for these Pcode signatures. Pcode is basically like a virtual machine instruction set, and so you're going to be writing signatures that recognize the binary bytes and things like that in the compiled Pcode. So we see down here inside the comment, whenever we're writing these signatures, we rely heavily on Dr. Bonchev's Pcode Dump tool for disassembling the Pcode. So in his disassembler, it provides both the readable disassembly output plus the raw bytes that correspond to the disassembly lines. And so we use that to look through there, look for what are the different ways that you can call mid, how are those represented in the Pcode instructions. And then we write our nice and so easy to read regular expression down there for picking out the bytes. And then in Yarra, we say that if we see more than 75 of those instructions in the Pcode, we're going to throw up a red flag and take a closer look, do something with this document. Now, we've also done some work in the area of looking for VBA source code, Pcode mismatches, because this is where the kind of like more obvious avenue to take with this is. So we've written an open source tool called VBA Seismograph, which is written in Python. It's up on GitHub. It has a MIT license. So basically, if y'all are interested in this, and especially if you have security products, please steal it and try to use it. So what the VBA Seismograph does is just looks through the Pcode, pulls out all of the defined functions, function names, variable names out of the Pcode, and checks, do these show up in the VBA source code? It looks for all of the string literals that are defined in the Pcode. Do those show up in the VBA source code? Looks at, interestingly enough, in the Pcode, it actually includes the comment lines that should show up in the VBA, so we check for those also. And if we see anything that are showing up inside the Pcode that do not show up inside the VBA source code, VBA Seismograph will throw up a flag and say this is something you need to take a closer look at. So that concludes the content of the talk. We have a website up that https://vbastomp.com that has links to some blog posts that we wrote that go into more detail about what we covered in the talk. Also, like links to the VBA Seismograph GitHub, links to Dr. Bonchev's work, and other things like that. So at this point, we can open it up for questions. Yeah, so we started to do like a. Okay, so the question was, okay, so we've been looking at different like obfuscations and modifications to that compressed VBA source code, and the question was, how about going from the other end? So you work with and mess up the Pcode rather than doing things with the VBA source code. So kind of going the opposite direction from like Carrie's example where she modified the VBA source code in there, you ran it, did something different. How about doing that from the other end where you modify the Pcode and now it doesn't match the VBA source code? So we did like a little bit of work with that. Since the Pcode's like a compiled instructions and stuff like that, it's a little bit less forgiving of like fiddling around with the values in there. So it's definitely possible to do it. It would take a little bit more effort than we had like time allocated to do it. So yeah. Huh? Oh yeah, that was really interesting. So the question is, what sort of prevalence in the wild are we seeing where the Pcode doesn't match the disassembled VBA source code? So we pull down like a bunch of maldocs every day from VirusTotal and run them through different analyzers to see what's going on with different campaigns and stuff like that. So we added the VBA Seismograph into that process, and we were expecting to see like really basically none. But we're not seeing none. We're probably seeing about 4 to 5 docs a day, where there are obviously functions that are in the Pcode that are not appearing in the VBA source code. From doing manual analysis on there, it doesn't look like the functions are like called or like really doing anything. But the fact that there's a difference there, like we think that might be like an artifact of the malware, of the maldoc builder that the people are using. But at this point, like we haven't dug into enough to figure out like how they're getting that to happen, because they're not just stomping over like all of the VBA source code like the way we've been showing in this talk. They have valid VBA source code there. They have valid Pcode, but the two of them don't match. Right? Uh-huh.
What malware family are you seeing that you are seeing? Is it specific like grouping that you're seeing, or is it kind of scattered?
It's okay. So like there's like a kind of low-level Retefe maldoc campaign that's going on, and like periodically, like whenever they'll have a maldoc template that will have this mismatch between the VBA source and the Pcode. We've seen some like other small campaigns that we have not been able to track down like what exactly the campaign it is. So they tend to be like much smaller campaigns that are doing this, like the big ones like ursnif and emotet and stuff like that. Those all, the Pcode matches up exactly with the VBA. So the question is, like, do we think that these may be the cases where things look like there's a mismatch, whether it looks like it may be a targeted attack or not? For the majority of them that I'm seeing, I don't think it's a targeted attack, because we'll see like maybe like 5, 6, 10 docs where they've like changed up like the document content, like what you would see when you bring it up in Word. But the Pcode and the VBA is exactly the same in it, so it looks like it's probably an artifact of whatever maldoc builder they're using. But we are seeing some where we have like one doc that we're not seeing anything like that showing up at all, so that potentially could be like a targeted attack. Okay, so the question is whether it is possible to get like multiple versions of the Pcode in there that are targeted towards different versions of VBA. From what I've seen of the Pcode, like I think there's like information like up at the top that we've seen that kind of says something about like the VBA DLL and stuff like that it's expecting to get. So
there are some hard-coded paths like in the actual OLE object that point to like the DLL path that it expects for the VBA, and we think that we're still trying to pin down like the exact combination of information that like of OS and Office version and the VBA version that's installed on the system that controls whether or not the Pcode will execute or it falls back to the VBA source. But we are at this point, our running theory is that if those paths don't exist in the VBA version and the DLLs aren't there, then it's not going to run. So trying to create multiple Pcode that would run on multiple versions, we haven't like debugged Word to see like where it's looking and what it's doing to see if we could trick it into doing multiple. So we're not 100%, but at this point, those paths lead us to believe that you'd have to have a specific Pcode. Time for probably one more question. Buddy? Good, cool. Thank you very much.